encapsulate this information. Let's move on to switch statements. While they might seem harmless at first, switch statements can quickly become unwieldy and difficult to maintain as your codebase grows. They often violate the open-close principle, meaning that you have to modify existing code to add new functionality. Instead of relying on switch statements, consider using polymorphism. This object-oriented principle allows you to define different behaviors for different types of objects. For example, instead of using a switch statement to determine the behavior of different shapes, you could create a shape base class with a draw method. Each specific shape, like circle or square, would then override this method to provide its own implementation. Now, let's dive into parallel inheritance hierarchies. This code smell occurs when you have two or more inheritance hierarchies that evolve in parallel, often requiring you to make similar changes to both. It's like having to update the design of two different websites every time you want to make a change. Parallel inheritance hierarchies often indicate a design flaw. They add unnecessary complexity and make your code harder to understand and maintain. To address this, consider refactoring your code to eliminate the need for parallel hierarchies. This might involve rethinking your inheritance relationships or using composition instead of inheritance. Let's talk about lazy class. This code smell describes a class that isn't really pulling its weight in the code base. It might have very little functionality, or it might be doing something that could be done more effectively elsewhere. It's like having an extra room in your house that you never use. It's just taking up space. Lazy classes add unnecessary complexity to your code base. They can make it harder to navigate and understand the overall structure of your project. If you encounter a lazy class, consider removing it or merging its functionality into another class. If it's not adding value, it's probably best to let it go. Now, let's address speculative generality. This code smell arises when you add functionality to your code just in case you need it in the future, even though there's no immediate requirement for it. It's like buying a whole set of tools when you only need a screwdriver. Speculative generality can lead to overly complex code that's harder to understand and maintain. It's important to focus on the current needs of your project and avoid adding unnecessary complexity. If you find yourself adding features just in case, take a step back and ask yourself if they're truly necessary. It's better to keep your code lean and focused on solving the problems at hand. Let's discuss temporary field. This code smell occurs when a class has a field that's only used under certain circumstances or for a specific purpose, leaving it empty or unused most of the time. It's like having a spare bedroom that's only occupied for a few days out of the year. Temporary fields can make your code more difficult to understand and maintain. They add unnecessary clutter and can make it harder to reason about the state of an object. To address this, consider refactoring your code to eliminate the need for temporary fields. This might involve moving the field to a subclass where it's always used, or finding a way to calculate the value when it's needed instead of storing it. Next up, we have message chains. This code smell occurs when you have a long chain of method calls, one after another, to access data or functionality deep within an object graph. It's like having to go through multiple layers of menus just to find a simple setting on your phone. Message chains can make your code difficult to read and understand. They can also be a sign of tight coupling between objects, making your code more brittle and harder to change. To refactor message chains, consider introducing intermediate variables to break up the chain or using the law of Demeter to reduce coupling between objects. Let's talk about middleman. This code smell occurs when a class delegates most of its work to another class, acting primarily as a go-between. It's like having a personal assistant who just passes your requests on to someone else. Middleman classes add unnecessary complexity and overhead to your code. They make it harder to understand the flow of control and can make debugging more difficult. To address this, consider removing the middleman and working directly with the class that's actually doing the work. This will simplify your code and make it easier to maintain. Now, let's discuss inappropriate intimacy. This code smell occurs when a class has too much knowledge about the internal workings of another class, often accessing private data or methods. It's like reading someone else's diary. It's just not cool. Inappropriate intimacy violates encapsulation and can lead to tight coupling between classes. It makes your code more brittle and harder to change, as modifications to one class can have unintended consequences for others. To refactor this, consider reducing the dependencies between classes. This might involve moving functionality to a more appropriate class, using interfaces to define contracts between classes, or simply reducing the amount of information that's shared between them. Let's move on to alternative classes with different interfaces. This code smell arises when you have multiple classes that do essentially the same thing, but with slightly different methods or properties. It's like having two different brands of the same product. They both serve the same purpose, but they come with their own quirks and instructions. Having alternative classes with different interfaces can make your code harder to use and maintain. It can also lead to code duplication, as you might have to write similar logic to interact with each class. To address this, consider refactoring your code to create a common interface that all of these classes can implement. This will make your code more consistent and easier to work with. Now let's talk about incomplete library class. This code smell occurs when you're using a third-party library that doesn't quite meet your needs. It's like buying a pre-built bookshelf that's almost the right size for your books, but not quite. While you can't directly modify the library code, there are ways to work around its limitations. You might consider creating a wrapper class that extends the library's functionality, or using an adapter pattern to bridge the gap between the library and your code. The key is to find a solution that allows you to use the library effectively without compromising the design and maintainability of your own code. This code smell describes a class that's essentially just a container for data with little to no behavior of its own. It's like a treasure chest that only holds gold coins. It might be valuable, but it doesn't do much on its own. While data classes aren't inherently bad, they can sometimes indicate missed opportunities for encapsulation and behavior. If you encounter a data class, consider whether there are any operations or behaviors that would make sense to move into the class itself. This will make your code more cohesive and easier to reason about. Finally, let's address refuse bequest. This code smell occurs when a subclass inherits methods or properties from its parent class that it doesn't need or use. It's like inheriting your grandfather's antique pocket watch collection when you don't even wear a watch. Refused bequest can be a sign that your inheritance hierarchy isn't well defined. It can make your code more difficult to understand and can lead to unexpected behavior if methods are overridden or not used as intended. To address this, consider refactoring your inheritance relationships. You might need to create a new base class that better represents the common functionality, or you might need to rethink whether inheritance is the right approach in the first place. That's it for today's video on code smells. We've covered 22 common ones, but there are many more out there. The important thing is to develop a keen sense of smell when it comes to your code. Remember, writing clean, maintainable code is a journey, not a destination. Just like you wouldn't want to live in a messy, disorganized house, you don't want to work in a messy, disorganized code base. So, the next time you're writing code, keep an eye out for these smells and don't be afraid to refactor. Your future self will thank you. If you found this helpful, make sure to like, subscribe, and hit the bell icon for more tech insights. Thanks for watching and happy coding.